Hello and welcome to the Holmes Lectures 2021. My name is Claire Fearon and I'll be taking you through the lecture today and next week as well. So both of the lectures this year are on the theme of women in STEM. So for this session today, where are the women in STEM? We're going to be looking at some of the statistics, some of the background, the history of why there aren't as many women as there are men working in STEM fields. And then next week, we'll be meeting some really cool women that work at Newcastle University as scientists and engineers and mathematicians and find out a little bit about their career journeys. So to start with today, in case you don't know, hopefully you do already, but in case not, STEM stands for Science, Technology, Engineering and Maths. So we're going to jump straight in with some statistics. So these statistics are from 2019, so quite recent. And this is quite an interactive talk, so you can kind of play along and have some guesses, and there's some games that you can play as well. So first of all, what percentage of women, or what percentage of people do you think were women within the whole of the UK STEM workforce in 2019? So of all the people working within STEM, how many of them, what percentage do you think were women? So if you want to take some time to think or have a chat about it with whoever you're watching with, then feel free to pause. If not, I'm going to tell you the answer. So the answer is actually 24%. So that equates to about 1 in 4. So for every 1 female, there would be 3 men. So that may sound fairly okay, but if you think about women make up 50% of the population, so then they're underrepresented in STEM industries because they don't make up 50% of the workforce there. And in some areas of STEM, the percentage is much lower as well. So we'll dive into some of them. So in the tech sector, what percentage of people do you think working there are female? Again, pause if you want to have longer to think about it. And the answer is 16.4%. So that equates to about 1 in 6 people in that industry are female. And then what about the engineering sector? Do you think that's better or worse? What do you think? I'll tell you the answer. It's actually 10.1%. So that is about 1 in 10. So if you imagine, say, your classes at school, if they were at the same ratio, say there's 30 people in your class, that would be like if there was only 3 girls in that class. So it's, if you put it like that, think of it like that, then yeah, there's not that many women there. And that's what we're going to look at today. Why is that the case? So going through education, the percentages are not always that small. So if you look at a GCSE level, so the exams that you take when you're kind of 15, 16, that's a fairly even 50-50 split because pretty much everybody has to do science and maths GCSEs. At A level, so the exams you do that you can do if you want to after GCSE, so when you're 16, 17, 18 even. Again, it's still 50-50, it's pretty good, even though you can choose any subject you want to do at A level. You don't have to do a science or a maths, but it's still about 50-50 for those subjects, male and female. But apprenticeships at the same level, only 8% of the people doing apprenticeships are female, so it's much smaller there. Apprenticeships in STEM, I should say. And then if you look at graduate level, so people getting a university degree in STEM, about 26% of the people graduating from STEM degrees are female. So again, you can see that that's narrowing up there at the top, and then in the workplace it's even narrower. And then if you go higher up in this, so if you look at higher up positions in the workplace, so kind of managers or senior manager levels, or even in education, so if you look at PhDs, which is a really high qualification you can get, the further up you go, the fewer and fewer women there are in the STEM industries. Why is that? Well, to look at why that may be the case, we're going to have to take it back and look at the history. So we're going to go back about 150 years to the Victorian times now, and we're going to talk about Charles Darwin. So you may have heard of Charles Darwin. He's quite a famous scientist. He came up with the theory of evolution, but that's not quite why we're bringing him up here. So Charles Darwin was quite forward-thinking in many ways. The theory of evolution was very controversial at the time. A lot of people thought it went against a lot of their ideas that they already had. But in many other ways, he wasn't so forward-thinking, and one of them was in his ideas about women. So he wrote quite a few books. You might have heard of The Origin of Species, which is where he outlined his ideas about evolution. Another book that he wrote was called The Descent of Man, and this paragraph here is just a little section from that, and it's quite wordy, a little bit difficult to read, but he essentially said that The chief distinction in the intelligence of the two sexes, men and women, is shown by man's attaining to a higher eminence in whatever he takes up. A woman named Caroline had read this and thought, is he really saying that? Is he saying that women aren't as intelligent as men? And so wrote him a letter, and then Charles Darwin wrote back. And these are even harder to read. Very old-fashioned handwriting, very tricky to read. So I've translated all of this to help you guys understand what was going on there. So this is my kind of version of what he wrote in his book. So I've made it a little bit more up to date for you. So he essentially said, men are better than women in everything they do, and if you wrote a list of the 6 most successful men and women in things like poetry, painting, sculpture, music, history, science, philosophy, then all the men would be better in all of those categories. And Caroline said, so she wrote him a letter. If it was 2020, 2021, she probably would have just tweeted him. So she essentially said, did you really say that women aren't as clever as men? And Charles Darwin got back to her and said, yes, I think women are superior in moral qualities, so he did give us that, but inferior intellectually, and it would be very difficult for them to become intellectual equals. So I don't know what you feel about that, but Caroline was having none of it, and she basically said that women have the same capabilities as men, but they're just not given the same environment or educational opportunities to develop their intellect and to kind of show that off. And at the time, that was very, very much the case. So women weren't expected to carry on in school for as long as men. They weren't expected to get challenging jobs or to kind of be scientists or engineers or think outside the box. They were pretty much expected to look after a household, look after a family. They weren't challenged and pushed in the same way that men were. So moving on from that, there's been a lot more progress since then, and we're coming up to World War II now in our timeline. So in World War II, things started to change a lot more for women because a lot of the men that were usually doing a lot of jobs were out fighting the war. So women had to step up and had to help out with these jobs. So one of the jobs that women did in World War II was that they were the first computers. So not the first computer scientists, but actually the first computers. And I'll let this video explain a little bit better than I can.
In 1946, the Army unveiled its top secret wartime project, ENIAC.
It's the world's first electronic computer.
It celebrated the machine's designers, John Mauchly and J. Presper Eckert. What the Army didn't tell the world was that the new machine had been programmed by 6 women mathematicians, the first modern programmers in history.
The problem the Army had during World War II with its long and medium-range cannons was hitting a target miles away. It turns out that weather had a big impact on the arc or the trajectory of the missile coming out of the cannon. But there was a differential calculus equation, and if you could put in one set of weather conditions for one gun and one missile, you could calculate the trajectory and you could figure out what angle to shoot the gun. The Army realized that it needed lots and lots of male mathematicians to calculate firing tables for artillery. The only problem was there were no math majors left. They were at Los Alamos, they were on the Manhattan Project. So the Army took a big breath and deigned to hire women.
So we were computing, so they called us computers, and I was hired for the grand total of $2,000 a year.
But even with 100 computers working flat out, the Army fell further and further behind. Vital guns lay unused, waiting for their firing tables. In desperation, the Army decided to take a bold gamble. It launched a top-secret project to build a new machine, one that could calculate thousands of times faster than people.
When the ENIAC was almost finished, the men, the engineers who were brilliant, looked around at each other and said, we need to find someone to program it for the ballistics trajectory. And they looked around, and from the group of about 100 women, they chose 6. And the women didn't have the security clearance to see the machine.
They had no books or anything to teach us how to program, and they gave us these great big block diagrams of the units of the ENIAC, and we were supposed to study them to figure out how to program it and how the thing worked.
These 6 young women set out to do what no one had done before, to program an electronic computer. In a feat of extraordinary genius, these first ever modern computer programmers figured out how to instruct the computer to solve in seconds what had taken them a week or more by hand. In doing so, they laid the groundwork for the programmers and software engineers to come.
So now we're expanding our timeline a little bit and going to look at some events that have happened from Charles Darwin's time right up to today. So this is a little activity you can take part in if you want to. So on the in the circle here, we've just got a few different statements and events that happened throughout the last 150 years. And your task is to just put them where you think they go on each of the dates on the timeline here. So if you've got a pen and paper, you can write your own timeline, or you can think it in your head. Feel free to pause and chat with the people that you're watching with and see what you guys think. So if you want to have a go at this, pause now, and if not, I'm going to go through the answers. So we'll start at the furthest away date in 1878, and here we have the University of London becomes the first university to allow women to be students on equal terms. So this was quite a big deal. Up until this time, universities only allowed men to be students and to graduate, but from 1878, the University of London at least let women in. Not all universities followed suit quite so soon after, but they were the first ones to let women in. Moving on quite a few years now to 1906, next on our timeline, we have that Alice Parry became the first woman to graduate with an engineering degree in the UK and Ireland. And then just 5 years after that, we have Marie Curie, who hopefully you've heard of, became the first person to win 2 Nobel Prizes. And that isn't just the first woman to win 2 Nobel Prizes, the first person ever. So that's a really huge deal. And then moving along to 1948, so just after World War II, we have got the University of Cambridge allows women to graduate. So notice the difference there in years from the University of London to the University of Cambridge following suit. And then moving on to the 1960s, we've got the first woman in space in 1964. In 1975, we've got that it is made illegal to discriminate against women in work and education. And then in 1982, we've got the second woman in space, so about 20 years after the first. Then moving on to 1993, for the first time, an equal number of men and women register for university. And that's not in STEM subjects, that's just across the board in all subjects. Obviously, we saw earlier that it's still not quite equal in STEM subjects. Then in 1999, we have the pay gap between men and women is 16.4%. Then in 2018, we have the Nobel Prize for Physics is awarded to a woman for the third time. And then 2009, the pay gap between men and women is 8.9%. So hopefully you've noticed the colour patterns that I've used in this. So all of the orange ones here relate to kind of university education. All of the teal coloured ones are Nobel Prize related. The purple ones are space, and the blue ones are more kind of work employment related. So if we look at the university ones to start off with, 1878, the University of London became the first university to let women in, but it took 70 years for the University of Cambridge to also let women in. So just because one university did it and that kind of progress change happened, it still took a long time for other places to catch up. And even then, it took even longer for things to actually equal out. And even now, they're not equal in all subject areas. So it just kind of shows that change is happening and change is coming about, and that is good, but it's not immediate. So there's still a lot of work to be done. And then with Nobel Prizes, Marie Curie made a huge breakthrough and became the first person ever to win 2 Nobel Prizes. But then in 2018, the third woman won the physics prize. So that's not a woman winning it for the third time. That's just the third time that any woman has won that. So between Marie Curie in 1911 and Donna Strickland, who won it in 2018, there was only one woman in between them winning the prize for physics. So it just goes to show there's still a lot of women missing from the kind of top of the fields in physics. And then even with space, the first woman in space took 18 years for the second woman in space to go up. So it's not like one woman was let in and then they just let all women become astronauts, or there was a flood of women wanting to be astronauts. It still took a long time for that kind of progress to be made, and even now there has been hardly any female astronauts compared to the number of male ones there have been. And then in the blue boxes, to do with work. So in 1975, it was made illegal to discriminate against women in work and education. So that meant that you can't give someone or not give someone a job because of their gender, and you can't not let someone onto a course because of their gender, like a university or college course. You also can't pay someone less because they're a woman. But even so, there's still a big pay gap. So you can see that that is narrowing, and hopefully by the time you guys are out working, it will be a lot more equal. But there's still kind of progress and change to be made here. So now we've looked at the history and the stats, we're going to move on and look a little bit at the psychology. So we've seen that people had these ideas about what women can and can't do, and women were kind of restricted in what they could do. Now women can do pretty much anything that men can do, which is great, but there's still some ideas that women are better at certain things and men are better at certain things. And some people think there's such a thing as a female brain and a male brain, and that certain jobs are better for the male brain. And I'm just going to tell you that's not the case. But we're going to look at where that idea has come from. So we're going to look at psychology now. So psychology is the study of the human mind. And lots of psychologists over the years have studied the brain and the cognitive differences, so the differences in how we think, and how men think and how women think. And they've done this by doing lots of different tests. And I'm going to show you some of the tests, and you can take part in them at home as well if you want to. So the first test that we're going to do is a test of spatial mental rotation. So on the left-hand side here, this first shape, your task is to try and, in your mind, rotate that shape and see which of the four shapes next to it match it. And it might be more than one. So you can kind of flip it, you can rotate it, however you can twist it in your mind to see if it matches up to any of these. And there's a couple more there as well. So again, feel free to pause the video and have a real go at this. There might be more than one shape that it matches on each row. So if you're ready, I'm going to tell you the answers. If not, pause. So for the first one, it's the first shape there. And I think the second one as well can also be rotated to match it. And for the second one, we've got, again, it's the first one. And for the last one, it's the second one fits it as well. And then the next test that we have is reaction times. So I'm going to show you a couple of examples of how psychologists would test people's reaction times, but the way I'm going to tell you guys can do it at home is slightly different. So in an actual psychology test, reaction times would be tested on a computer, and the person would be staring up at a screen and they'd have a button or a mouse or something in front of them that they could press or click. And they would just be asked to click when they see a shape appear on the screen. So kind of like this. And that click would kind of feed back into the computer and work out how quickly they press it from the shape flashing up. Another version of this is called the go, no-go test. So this kind of takes it to an extra level. And instead of just testing when they press for anything on the screen, it's kind of testing that you actually register what is on the screen before you click the button. So for this example, you would only be asked to press the button when you see an arrow pointing left. So you have to kind of pay attention to it and not just see something and press a button immediately. You have to kind of actually think about it a little bit more. So it's obviously going to slow you down a little bit, but it's just still able to test your reactions. So you wouldn't press for that, would for that, wouldn't for that, would for that. So now I'm going to show you a version of a reaction time test that you can do at home. So to test your reactions at home, you just need a ruler. A 30cm ruler works best for this. And all you have to do is have someone help you and hold the ruler up against the edge of a table. And if you hold your hands like this, just beneath the edge of the table, and then the other person will let go of the ruler and you just have to catch it as quickly as you can. So they're not going to tell you when they let go, so you just have to be kind of paying attention and ready. And the shortest distance that you get, so you can measure that in the centimetres on the ruler, then the quicker your reaction time is. So you can have a go and test it out with your family and see who's quicker. So next up we have a memory test. So for this one, I'm going to show you some shapes on the screen and you'll have 20 seconds, so I'll count for you. So don't pause the video and cheat. And you just have to try and remember as many of the things on there as you can. So don't be writing anything down. Just for those 20 seconds, just stare at the screen, look at the shapes that are going to appear here and try and remember them as best you can. And then after the 20 seconds are up, write down as many as you can. So if you need to go and grab a pen and paper, do that now. And if not, I'm going to start. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, and stop. Now write down as many as you can remember. So if you want a little bit longer to do this, then feel free to pause the video. Okay, so this is all the shapes again. So how many did you get right? Did you write down any that weren't there? You can write down your scores, compare it to your family, people that you're watching with. And next up we have a perception test. So for this one, I'm going to flash up some dots on the screen and they're going to come up really quickly, and then after like 2 seconds, another set of dots will appear again really quickly. So you have to pay attention, write down your answer really quick, and then look up at the screen again to make sure you don't miss it. So there'll be 4 rounds of dots. Okay, so really quick, we'll start off. Okay, so did you get them? The pattern was 4, then 2, then 7, and then 3. So up next we have a cognitive speed test. So this kind of tests how quickly your brain processes information. So you may have seen something that looks a little bit like this before. This is called a Stroop test. So for this test, you just have to say the colour of the words. So you don't want to be reading the words, you want to say the colour that the words are written in as quickly and accurately as you can. So the first one would be red. Again, pause the video, have a go as many times as you like, get the people around you to help as well. And you can even have a go of actually just reading the words as they are written. And you'll see that that is usually a much easier task. So the reason that this is hard is that your brain is kind of trained to see letters put together and read it as a word and read that and recognize that. So when you see a word written there, your brain's automatically you're not really having to think that hard, you're just picking up and reading that word. But when you're going through this and telling me the colour the word's written in, your brain's still trying to read that word, but you're also figuring out the colour. And because both of those bits of information are both colours, then your brain's kind of having to figure out which one you're actually wanting to say. So it can kind of slow down the whole process compared to if you were just reading the words as they're written. So how did you guys do in that? Did you find these tests easy? Did you find them hard? These tests have been done hundreds, thousands of times in numerous different studies with loads of different people doing them. And on average, most of the studies find that men, on average, are better at mental rotation. So the first one that we did with the shapes, motor skills, which we didn't test here, and reaction times. And on average, women are better at verbal skills, so things using language and speech, recollection, so the memory task, and perception, the one with the dots flashing up. Did you find that fitted with your family? Don't worry at all if it doesn't, because when we say men are better at one, women are better at the on average bit is really key here. Because if you plotted all these scores on a graph, say this was for mental rotation, for example, and the score, how many you got right is along the bottom, and the number of people that got that score is along the side. This is what the graphs would look like. So yes, the white line, the males, is slightly ahead of the black line, the women, but it's not that every single man scored better than every single woman. It's just a slight few. But you can see most people are in that triangle in the middle. Most people's scores fall somewhere around there, no matter what gender they are. So really, it doesn't mean that much. And some other studies have actually found that when you do these tests on really young children, so maybe 3 or 4 years old, there's no sex differences between them on any of these abilities. So that kind of suggests to us that these things are learnt throughout your life. and they're picked up from the environment, from things you do, so maybe even the toys that you're given as a child. So often toys are kind of gendered, so boys are given one type of toy, girls are given another. And one of the big things that boys often get is kind of construction toys, things like Lego and stuff like that. So you might have noticed that the mental rotation task that we did at the start kind of looks like building blocks. So you could argue that boys get more practice doing that kind of task because they're playing with those kind of toys from a young age. But you can change and practice any of these skills and improve yourself on any of these things if you want to. And if you want to do a particular thing for a job, then you can practice and train and learn how to do the things that you need to do for that job. So there's nothing to say that because you're male or female, you can only do certain tasks or you're really good at certain tasks. That's completely not true at all. And you can improve and get better on anything that you want to. So what we've looked at so far is that there isn't really any such thing as a male or female brain. There's not one thing that boys are good at or one job that women should do and not do. Everything is open to everyone and you can improve on anything. And it's kind of the history and the cultural stereotypes and things that have led to this status that we are in now, where there are fewer women in STEM. And hopefully as things continue and we get more and more women in STEM, and you'll see more and more women in STEM, and even next week, when you'll get to hear from some of their stories, you'll see that women are scientists and engineers too. But why do we even care that women are or aren't scientists? Why does it matter? Well, I'll tell you why we need more women in STEM. There's a few different reasons, and one of them is that diversity in general on all aspects, so not just necessarily sex or gender, diversity brings new perspectives. So if you have people from different backgrounds, different walks of life coming together and working on some sort of research or some new kind of invention or engineering thing, then they'll have different perspectives to bring to the table, and hopefully whatever they're researching or creating kind of reflect people from different areas and different backgrounds as well, so it can be more representative. Research is also better when gender is considered, and gender is more often considered if there's more diversity of gender in the team that is doing the research. So one big example of this is obviously years and years ago now, when seatbelts were first invented, they were only really tested on kind of crash test dummies that were shaped like men. So women and children died more often in car accidents than men did because the seatbelts didn't fit them properly. Obviously that's changed and things have progressed since then, but there are a few other little things. So things like heart disease, most of the research is generally mostly done on men rather than a varied sample, and heart disease in women can present very differently to what it does in men. So sometimes their symptoms aren't picked up on and they aren't diagnosed as quickly, so then they can have a much worse prognosis further down the line. And then lastly, we just need more people in general. So the UK hugely needs more scientists, engineers, more mathematicians. So the more people that we can get involved in doing these courses at university and doing these careers further down the line, then the better. And there are more women that aren't doing STEM than men who aren't doing STEM. So it makes sense to kind of focus on the women and show them that they're more than capable of working in these areas, and that these areas are a lot of fun and really interesting as well. And I imagine a lot of the things that you'll want out of a job. So if you want to kind of help people, if you want to work on kind of really innovative future thinking things, you want to use creativity in your job, you want to work as part of a team, help the environment, help society in general, all of these things are included in a lot of STEM jobs. So it's a really key area that I think could be a lot of interest to you. And next week, in the next video, I'll be talking to some women that are doing these really cool jobs, and you'll get to hear from them what they actually do and why they enjoy it so much. And perhaps you'll get some inspiration for what you might want to do in the future too. So in the meantime, for next week, there is a little task that you can do if you want to, and it's called People Like Me. So this was developed by an organisation called WISE, which is Women in Science and Engineering. And they kind of found that girls tend to describe themselves with adjectives, whereas boys describe themselves using verbs. So they came up with this sort of personality test that uses adjectives. So you can download the sheets and all the information you need on our website. So all it is showing you is some ideas, some things that might fit you. Just shows your preferred way of working, but that doesn't mean that you can't do other things. So if you think about it as like if you're left-handed, say, you prefer writing with your left hand, that's how you usually write, but you can write with your right hand, and if you really wanted to, you could practice loads and get really good at writing with your right hand, and vice versa. So this is a similar kind of thing, so it's just showing you where would be kind of a good fit for you, but it's not not necessarily your only option. So hopefully I will see you guys in the next video when we'll be chatting to lots of really exciting women in STEM.